historic temple, Meenakshi temple, and these are other temples in the southern Tamil Nadu. So these were, built using eco-friendly construction practices, using granite stone, more natural and local materials. So this was how the construction industry was long ago, heritage buildings. Whereas if you consider the traditional housing projects in southern India, you can have a house like this with a central courtyard, which permits ample daylighting, ventilation into the house. There is rainwater harvesting facilitated in the house. So it's more kind of, seamlessly living with the nature closely in a setup like this. Whereas if you consider the modern construction practices, we often go for high-rise residential buildings, commercial buildings, and one of the concern is we do spend more energy for operating the buildings. Typically, the service life of built environment is about 50 to 100 years, and significant amount of energy is used for periodical, day-to-day operation of the building in terms of lighting, in terms of ventilation, in terms of services, air conditioning, and so on. So one of the question I would like to discuss with the audience is how do we align the modern construction practices along with the traditional principles and culture, so that we live a more eco-friendly life and reduce the impacts on the ecosystem. So this is a question all of us need to think about in the coming years if we really want to move towards net zero. Now, there are different perspectives related to sustainability. So in addition to the three pillars we have discussed, we do need to consider the temporal dimension. How does sustainability varies across the time scale? We do need to consider the spatial aspects. What is the effect of geographical location on sustainability metrics related to built environment? So this is relevant for us. The global vision for built environment sustainability from a civil engineering perspective, I would like to share two key concepts from this figure. One is how do we move from a non-renewable natural resource to a renewable natural resource? Moving to a renewable power sources is very important from a sustainability perspective. The second is in the end of life, once a building is demolished, how do we recover useful resources from the built environment and use it for product manufacturing? So thereby we are trying to connect the end of life back to the product manufacturing, which will have two benefits. One is we are reducing the amount of waste that goes to landfill. Second is we are reducing the mining operations for new resources. So resource recovery and circular economy along with renewable sources for built environment will help us to move towards net zero goals in the future. So I'd like to highlight one example from our own campus, IIT Madras campus. We have a residential building, 2-floor building, made of glass fiber reinforced gypsum panels. So basically, the GFRG panel is manufactured from gypsum waste produced from the fertilizers industry, and we use that as a useful resource in the built environment. So this is one example for circular economy, where we are trying to connect the waste generated from one sector as a useful resource for another sector. So this is a perfect example. This photo shows the landfill gypsum waste near the fertilizers industry, and the photo below shows a cross-sectional area of the GFRG panel. So as you see here, you have both interior surface and exterior surface. In between, you have cavities. These cavities are used either for services or the alternate cavities are filled with concrete to increase the stability of the GFRG panels. In our department, we have conducted several sustainability studies, and one of the study completed by our former doctoral scholar on assessing the embodied energy of conventional residential buildings and GFRG buildings, and we compared the differences between the both. And here are the key benefits of using this technology for residential buildings. First is we are able to reduce the self-weight by 25%. The cement is reduced by 25%. The use of steel rebar is reduced by 36%. Sand is reduced by 44%. So these are savings from a material perspective. In addition, because of the use of prefabricated panels, we are also able to reduce the construction time by 3/4, the workforce requirement by 50%, and there is some reduction in the material embodied energy also. So these are some benefits because of the use of prefabricated technology, especially when the prefabricated panels are produced from waste generated from other sector. So this helps us to move towards sustainability. So to summarize this, if we want to promote sustainability more from a strategic perspective in the built environment, in a building planning, design, construction, operation, maintenance, and the end of service life, we have to consider three perspectives. One is what, second is with what, the third is how. What refers to the requirements and functionalities of the new project. So there is an emphasis on making our needs more responsible. Do we have a sustainable requirement for the new facility? Second is with what refers to the use of sustainable resources, how to use materials and technologies with low carbon, low emissions, and low waste. The third is sustainable processes, how to green the construction processes, to reduce the amount of energy used. So this is more from a sustainability from a strategic perspective. Now, I would like to give the basics in terms of life cycle energy use in built environment. So a typical building life cycle has these four major phases. First, we consider manufacturing of materials. This is often called A1 to A3 in the international standard. Then follows the construction process at site. So here A4 represents transportation to site, and A5 refers to on-site construction by the contractor. The third phase is B1 to B7, operation of the facility as well as the maintenance, repair, renovation of the facility. And then finally, we have the demolition and dismantling of the project. This is called C1 to C4, demolition, transport, and landfilling of waste. So there are different terminologies related to energy consumption in the built environment. So the energy used for materials manufacturing is called indirect embodied energy. The energy used for direct construction at project site is called direct embodied energy. The sum of both refers to the initial embodied energy. The energy used for the operation phase is called operating energy, and then the energy used for maintenance and repair is called recurring embodied energy. So in some buildings, the recurring energy is less than the initial embodied energy, whereas in other type of buildings, the recurring embodied energy is several times higher compared to the initial embodied energy. So this is something to look into in the building planning perspective. The energy used for demolition is called demolition energy. Now, in Indian perspective, if you consider facilities which are fully air conditioned, typically the operating energy is about 70 to 80%, and the embodied energy is about 30 to 20%. So that gives a breakup of the construction versus operation for built environment in Indian context. So there is more focus on life cycle thinking nowadays compared to looking into only the operational phase now. Also, we focus more on global warming potential of the built facility. So life cycle thinking is very important to promote true sustainability in the society. This calls for considering the entire life cycle of the built environment, starting from the mining of materials, manufacturing, transport, construction, operation and maintenance, repair and renovation, and demolition. And then we do have recycling, which is connected back to the manufacturing. So to achieve net zero by 2070, as per the government of India, we do need to consider life cycle thinking to understand the true sustainability of new technologies. For example, insulation technologies, solar PV, glazing, EV vehicles, finishing materials, services, envelope and facade. So when we select a new material or a new technology in the context of net zero, it is important to consider the entire life cycle related energy use, emissions, and impacts, so that we make a informed choice in building planning. Also, the construction industry today is more global in nature compared to earlier days. We do have global construction supply chains where resources are mined from one continent, processed in some other country, and used in developing countries like India. So there is a significant amount of supply chain impact in modern construction practices, especially if you see the mega projects, infrastructure projects, where we have high level of interdependence among multiple stakeholders. We often import materials, we often import new technologies from Europe and America. So one of the questions we would like to think is, how to optimize the global supply chain related impacts in the context of net zero by 2070. The related concept is development of embodied energy database for new countries, for developing countries, emerging economies. So this is a snapshot from a database from UK, where they have systematically compiled the embodied energy of different materials, embodied carbon for materials. The availability of reliable data on embodied energy and embodied carbon for materials, technologies, and construction processes is a prerequisite to move towards sustainability. So I'd like to highlight that the technical specifications of materials significantly influence the energy intensity, carbon intensity of new materials. So you can see from this snapshot the difference between a recycled material and a new material, for example, stainless steel. The difference is significant. So whether the material is recycled or not has a huge influence on the energy intensity and carbon intensity of the new buildings to be built. The other examples, there are highly energy intensive materials used in built environment. For example, you have glass, insulation, carpet, lithium. So this, if you see mega projects like airport projects in India, we do use carpet for flooring. So you can see here, carpet is one of the energy intensive material compared to glass or compared to cement or brick. So this is something we have to consider, how to use less energy intensive materials in the future, especially when we go for mega projects. We have to consciously avoid using energy intensive materials like carpet. And also we can see lithium is one of the highly energy intensive materials. This is used for EV vehicles, like EV two-wheelers and cars. So we have to pay attention to the energy intensity of batteries, energy intensity of replacing the batteries, and the impacts related to disposal of batteries in the society to promote life cycle thinking. So there are different factors influencing the sustainability aspects of built environment. For example, location, time, fuel mix, source of raw materials, quality, technology, packaging. So these factors have to be taken into account when you promote, when you want to assess sustainability parameters for built environment. We have conducted several studies here at IIT Madras in terms of materials, technologies, and processes. These helps us to consider sustainability as a planning parameter in addition to time and cost during building planning. So I'd like to highlight that there are different stakeholders in the society. There are different stakeholders who are involved in the built environment life cycle. Each stakeholder has different expectations in terms of sustainability. For example, developer may have some other target. Architect may look into sustainability from a different perspective. Academic institutions, research institutions, PMCs, consulting firms, economists, government, clients. So each stakeholder looks into sustainability from a different perspective. It is important to promote true collaboration among all the stakeholders to promote sustainability. So in this context, I would like to highlight a few recommendations from this Annex 72 committee from International Energy Agency. So this committee focused on life cycle impacts of buildings during the last 5 years from 2017 to 2022. And I was fortunate to represent India in this committee and contribute to the development of some technical documents. So I would like to highlight a few important recommendations given by this IEA Annex 72 committee to promote sustainable low carbon built environment in the future. First, we will look into the role of government and administration. How does the government contribute to promoting net zero? One is, we should define legally binding target for global warming potential for buildings. Uh, Set up national LCA database in the country so that it is useful for early phases of building planning. The third is how to promote consistency in the LCA database, LCA results in the country. Fourth is set up research programs to promote, to develop sustainable materials and sustainable technologies. The final recommendation is develop negative emission technologies. Negative emission technologies is, for example, carbon capture, carbon sequestration. So this is better than buying carbon credit from a third party because we have full control on the technology use. So these are examples on how the government can contribute to net zero in the coming years. Second is what is the role of investors, banking institutions, and financial institutions? Uh, First is promote investing in building projects with low global warming potential, low impacts, low resource use. Second is demand the integration of sustainability metrics in the building planning and design phase. Third is be informed about regulations and target values for global warming potential related to built environment. So this can be upfront demanded during the building planning phase. Consider sufficiency. Sufficiency means build only what is needed and build less. And consider renovation of existing buildings compared to new building construction and demolition. Demand the quantification of global warming potential for risk assessment, for economic evaluation, which can be used as a precondition to invest in new building projects. So these are some examples on how investors and banking institutions can influence sustainability in the planning phase. The third example I would like to highlight is research organizations, for example, universities, research institutes. One is set up knowledge center, set up information center on sustainable construction. For example, at IIT Madras, we have technologies for low carbon and lean construction set up, established as a part of Institute of Eminence scheme here. Develop courses on environmental sustainability and life cycle assessment. So we do offer a graduate level course on sustainable construction here during the last 12 years. Set up training modules for architects and designers to promote low carbon materials, low carbon building design. That's the third example. Fourth is promote research in the areas of life cycle assessment, reduce the impacts of building technologies and building materials. The fifth is development of courses related to negative emission technologies in the future. So these are some examples how academic institutions can contribute to move towards low carbon economy. The third is designers, architects, engineers. So these stakeholders have a very important role to play because they are the one who develop different types of drawings in the early phases of building planning, architectural drawings, design drawings, finalizing the requirements, finalizing the project budget, and so on. So I have given different examples here. One is support the client and target setting. How to set the target in terms of functionalities, in terms of the budget, in terms of the resource consumption and global warming potential. Increase the adaptability and longevity of buildings, have long life so that you reduce the waste sent to landfill. Third is develop digital documents related to buildings. For example, we are talking about material passport, building passport, digital permits. So all the information related to the built environment is available in digital format, which can be used for facilities management. It can be used in the future. Then encourage evaluating multiple design options using LCA plus BIM. Nowadays, we have many LCA software tools available, which can be integrated with the building information modeling software tools, so that in real time, you can evaluate the environmental impacts of the proposed facility in different stages like LOD 100, 200, 300, and so on. So we strongly need to use digital LCA software tools in the early phases of building planning. How to use reliable tools to quantify emissions, impacts, and resource use in the early phases of building planning. The accuracy of tools is very important. Accuracy of data sets used, accuracy of logic used in the tool, that is also very important. Then we need to encourage architects and designers to attend educational modules, educational courses on sustainable construction and LCA. Promote circularity, recycled materials, low impact, and promote the concept of design for disassembly. That means how to make buildings more modular so that you can reduce the amount of waste generated in the end of life. How to lower the operating energy demand for the proposed facility. How to promote refurbishment instead of new construction. So these are some ways in which an architect and designer and engineer can influence sustainability in the building planning phase. Then the role of operators of EPD programs, LCA database providers, and the agencies which provide certification schemes and eco labels for materials. Some examples are given here. For example, follow the international standards used for LCA, use of environmental indicators as per the international standards, ISO standards. Prefer absolute target values instead of using relative values compared to a virtual case. Introduce a binding target value for life cycle based emissions of buildings. Be cautious in dealing with the environmental credits attributed to the built environment, in particular if it is borrowed from the future generation or from a third party. This is something emphasized as per the policy towards net zero. It will be better to have our own negative emission technology rather than buying an environmental credit from a third party. So that is the key concept here. Then how to ensure the consideration of product manufacturing phase, operational phase, end of life phases, C1 to C4. Also the transportation to the project site A4 and the construction A5. Thereby, we would like to promote holistic life cycle thinking in evaluating a building option. How to assign and require a single life cycle inventory database to establish LCA for products and systems. These are some examples from the operators of EPD programs. Then comes the manufacturers. Construction manufacturers play a major role in reducing the energy footprint, carbon footprint of buildings. Some initiatives related to manufacturers are given here. For example, set up a roadmap for net zero from a manufacturing perspective. How to generate environmental LCA data through the EPD programs. This EPD concept of EPD is gaining momentum in India. Many companies are developing EPD data sheets for materials in consultation with LCA consultants. How to purchase electricity from a renewable resource with guarantee of origin as well as with renewable energy certificate. So this is another example. Reduce environmental impacts, resource use, and global warming potential for all the processes. How to optimize the supply chain process, with the use of recycled materials, achieving energy efficiency, circularity in the manufacturing phase. The other important aspect is how to bring in suppliers of raw materials to promote, the reduction of GWP. So this is a responsibility of the manufacturer. Then following international standards is an important aspect, promoting transparent LCA database so that there is a consistency across all the stakeholders. The final recommendation is encourage manufacturers to invest in negative emission technology rather than purchasing CO2 emission certificates from a third party, primarily to reduce uncertainty, to reduce future risks related to carbon credits. Construction companies have to reduce emissions, impacts, and resource use, considering the new construction, deconstruction process, supplies of all the raw materials, and the transport logistics related to construction. They also should focus on controlling the amount of waste generated at the site, recycle the waste at the project site. Real estate agents have to encourage sharing data on emissions, impacts, and resource use. From the perspective of owners who want to sell the facility, encourage potential buyers to ask for the data and report environmental data for the new development. So basically, we have quantitative data available for new customers, both from the buyer perspective as well as from the seller perspective. Users and tenants, this is the last stakeholder. What is their role in moving towards net zero? Question your demand, optimize your requirements, use emissions and impacts and resource use as a key criteria in selecting buildings, use energy and water economically, use energy carriers that have low footprint in terms of CO2. So these are some examples. I thought it will be very useful for you to share from the this IEA Annex 72 committee, which was completed recently. Now, I will conclude my presentation in few minutes with a few examples from India. Sorry, something is happening. Yeah. Okay, some issue with the system. One is this lifestyle for environment. This is promoted by the government of India. This is one of the important initiative to adapt a lifestyle to promote sustainability in a developing economy. For example, you can sign up for this pledge, get a certificate. So user behavior, user preferences have a strong influence on promoting sustainability. This is one example I would like to highlight from an Indian perspective. Uh, Second is we do have several uh, standards available at the national level. For example, National Building Code of India, Part 11, Approach to Sustainability. This will be a very useful resource for all the stakeholders for us in building planning, building design. Second is this Indian Standard 15883 from the Bureau of Indian Standard. This has a specific chapter, Part 11, on sustainable management. More from a construction perspective, this will also be useful for you. So this is the last one. I'd like to highlight the contribution from IIT Madras towards this Annex 72 committee. We did support development of guidelines for establishing the easy to use LCA database in a developing economy. So this was supported from IIT Madras, which will be useful for the future. And also we have several studies completed here in terms of understanding the sustainability parameters in terms of life cycle energy analysis, in terms of green buildings. And we have created awareness among the graduate students who are going into industry during the last 10 to 13 years. So I hope this will create a positive impact in the society. So with this, I conclude my talk. Um, the earth has enough resources for our requirement, but not for our greed, as said by Mahatma Gandhi. So thank you very much for your kind attention. Thank you.
Thank you so much, Mr. Kumar, for this very, detailed and very informative presentation. I hope all the people who are attending this event, they have really got great insights into your presentation. Uh, 5, 6 key points which Mr. Kumar has highlighted are very, very important. One, he talked about sustainable construction, which is going local with the local resources, which is a need of our. Then he has talked about our legacy of old age architecture, which we need to adopt in this modern era. And then he talked about circular economy, where he is talking about using the waste which is generated at each life cycle of a project, which can be utilized in the project itself or can be used across various domains. Then he has also highlighted the importance of education and research institutions in training development of the various stakeholders which are involved in green building construction. He has also talked about standards and certifications, which all the developers should make use of while developing the projects. And then at last, he has also talked about construction ecosystem where all the stakeholders need to work together with each other, whether it is buyer side, whether it is seller side, either it is manufacturers or service providers. I think this presentation has given us a 360-degree view of the sustainable development which should happen in construction industry. Thank you, Mr. Kumar, for this very informative presentation. Now, I will request Mr. Han to give his presentation, and then we can take it from here. Thank you so much. Mr. Han.
Hi there. Are you able to hear me?
Yeah, it's audible.
Okay, great. And you're able to see my screen as well, yeah?
Yes.
Yes, so thank you to the previous presenter. I learned a lot, and it's a lot of detail actually. I'm afraid I might have to rush through my presentation a little bit. My fault, because when I saw the program, I did not factor I was actually 2.5 hours ahead of you guys. So I need to make a hard stop in about half an hour. But yeah, it should be well sufficient to cover the content. So, in the journey towards net zero, I'd like to speak a bit more about translating our sustainability goals into business value as we're pursuing, in this case, sustainable urban renewal. Now, what that means is basically taking either an existing plot of land and making it better, or really taking an existing building and turning it around through sustainability performance. But first up, we all know, of course, in the built environment industry that, first of all, global temperatures will rise up to 4 degrees or even more by 2100 from pre-industrial levels in 1900. And buildings account for close to 40% of greenhouse gas emissions. And if we're talking about Asia and developing Asia and rapidly urbanizing Asia, this figure could actually be higher, up to about 50%. And as a result of the UN, I believe it was COP21 back then, the Sustainable Development Goals were actually developed, out of which the organization I'm working with, CAPL, we have agency in about 10 out of 17 of these goals. So, for instance, if we're in the real estate business, good health and certainly clean water and sanitation would be enabled by our business. Likewise, with sustainable cities and communities, of course, with climate action. Right. We don't basically venture to, for example, solve other things like the hunger issue and so on, although, of course, there are many industries out there that can do that. What we do, what we can do, however, we do within our control, and we do try to minimize as much as possible. And at a personal level, of course, this is not my original drawing, but it's something that's a bit lighthearted that that's able to make you take a look at how your lifestyle is. For example, if we've taken a cruise or a business class flight recently, of course, that's a bit excessive. There are ways of actually controlling that as well. That being said, much of I would say South Asia, much of India is actually living a vegan or a vegetarian lifestyle. So good on you guys. That's something that our population here in Southeast Asia can also learn from. But when you talk about the building industry, a new build has a minimum positive impact, adaptive reuse somewhere in between. Of course, you're taking existing embodied carbon, you're keeping it, and you're upgrading the building. And of course, the no build option has the most positive effect. However, this is the World Green Building Week, and if we're talking about no build option, more than half of us in this room or in this virtual room will be out of a job. So that's no question. And indeed, we need to upgrade our environments in order to make them attractive, make them livable, and adaptable for modern living. So, what is CAPL doing about sustainability? Just a quick introduction to the company. So, traditionally, we're more than 50 years old. We've been in the shipyard as well as the development business. At some point, we're one of the corporates in Singapore that actually owned a bank. Now we've moved on to a fund management and investment arm or investment company that looks at up to 200 billion of funds under management by 2030. And as at June 2023, that's a few months ago, we had a fund under management of about 53.2 billion Sing dollars. That's somewhere around more than 40 billion US dollars as well. Out of which 62% of that fund is actually in real estate, which is why we are focused heavily on promoting sustainable real estate through real practice and through real measurements. And that is through infrastructure, real estate, as well as connectivity. And in doing so, if we go asset light, for instance, if we go from a traditional build and develop and sell model into one that's asset light, that's also one way of saving our carbon emissions. And in realizing our capital decarbonization vision, I would say basically that what we're trying to do is to take a science-based approach through our science-based targets initiative and look at refocusing our portfolio on urban solutions, investing in sustainability-related innovation on renewables as well, and also design a lower footprint type of built environment. And this is basically done through an ecosystem of different solutions providers, including energy as a service, and that's where we pay upfront for your energy capital expenditures. For example, a new chiller system that's more efficient, and over time you can pay us back like as an installment plan. And also with, for instance, the generation of renewables as well as energy management solutions. Now, that's the business pitch side of things, yeah? We want to talk a bit more about how we're actually decarbonizing. So in 2023, we've got an active goal of actually reducing our Scope 1 and 2 emissions by about 25% from 2019 levels, pre-COVID levels, gearing towards a Vision 2030 goal of reducing Scope 1 and 2 by 2025 and going completely net zero by 2030. So, of course, Scope 1 and 2, not to turn this into a lecture, but Scope 1 and 2 basically are direct and indirect emissions, resulting in this case from your company building itself as well as your vehicles, and Scope 2 resulting in this case from energy that you consume, for instance, from the grid. So once again, reducing Scope 1 and 2 through retrofitting rather than rebuilding, through going for low carbon and low consumption type of building materials as well as vehicles, electric vehicles, for instance, and in this case for electricity supply, reducing our consumption through more efficient systems. We are also starting our voluntary reporting on Scope 3, and that's supply chain, which the previous speaker also mentioned about. And I think that value and supply chain needs to be optimized in terms of, in this case, carbon output, as well as emissions. Which leads me to sustainable urban renewal, which is our endeavor of actually turning an existing building into a great building through sustainability solutions and into a great place with what we call our enterprise solutions. So these enterprise solutions could be the provision of amenities like flex spaces, like shared spaces, and also in this case, I would say providing, in this case, common programming where during every festival, the different tenants of the building could also come together. And we've got projects in the following markets. We've got projects in China, in India as well, in the cities of, in this case, Bangalore, as well as Pune, and also prospects in Mumbai. We're also looking at, of course, assets in Singapore and South Korea with a possible expansion into other Asia-Pacific markets. And how we perform this basically is through a whole stepwise approach. So based on, first of all, you have got the base, which is a renovation versus rebuild. And then there's the facade improvement, the energy improvement through, in this case, your mechanical systems, your energy regain through renewables, energy optimization through lighting, water savings, as well as other building solutions and controls. And if you cascade all of these savings, you could actually save both the energy and carbon from about 20 to 50%. And of course, if you turn that into a monetary equation, you could be saving more than 1 million per asset, $1 million US per asset every year, which works out towards a higher net operating income as well. These are kit or parts, so these are existing solutions. You also see these bubbles that are dotted in white. Now, these are solutions that we constantly look out for, that we constantly try to prospect, and these new prospective solutions are part of our global SIRS solutions ecosystem. And when you apply that onto, in this case, a nominal building, basically you've got a whole series of different solutions that not only work, but also work well with one another. And on the enterprise solutions part, it's basically an integration of customer experience as well as app-based strategies. So basically, you've got your apps to, for example, book your meeting rooms, to book the commons facilities, as well as to detect how the performance of a building actually will be. So it combines both customer experience and sustainability. And one of the examples of us actually applying this project is an asset in South Korea. So this is in Seoul, the capital of South Korea. And it's a 40-year-old building that immediately faces the traditional royal palace. So it's in a very, very good site, nice location, just off the center of the CBD, on the fringes of the central business district. And we're turning the building around by expanding its GFA, by maximizing its potential, but also keeping as much structure as possible. And if we map the decarbonization pathway through the Climate Risk Real Estate Monitor, or the CRAM pathway, we're looking at where the asset is right now and where it needs to be at 2050, which is that green sloping line that you see. So the first tranche of activity can happen within the first 5 years, and that's basically taking, in this case, an energy savings or a suite of energy saving solutions. Likewise, in the subsequent tranches, by continual improvement through implementing building solutions. And these are the different approach that we take: facade, ventilation, cooling, and so on. Basically, these are what we call our play cards in order to achieve these energy savings. Collectively, you'll save about 30% over the baseline, with more than Singapore dollars of 1.2 million per annum of savings. Closer to home, or our home in this case, this is the building in which Keppel is housed. It's our headquarters. It's a 21-year-old building that, through these solutions, not just architecture, but also in terms of mechanical and engineering, as well as digital solutions, we've managed to save quite a bit of its consumption. Exactly how much, I'll share with you a bit more, but on the left are images that were pre-2019, before its renovation, and on the right, post-2019, which is where we are today. Right, so the lobby has been upgraded to match, I would say, more recent trends in architectural design as well as interior design. And in this case, we've got our level 2 business lounge, where different business units can actually book their meetings, and where the Keppel group comes together for their meetings as well. With lighting savings, we've had an intelligent lighting solution that led to 70% lighting savings over traditional T5s, and the payback with a government grant was less than 5 years. We've also introduced a air handling unit fan system, which, by virtue of the blade design and the fact that it's electronically commutated, meaning there's no friction, there's also some energy savings to be had. So up to a fan power savings of about 46% with a 1.5-year payback. We've also introduced a cooling tower water management system for the cooling tower, and this is a chemical treatment system that decalcifies the calcium buildup that you would find in the pipes of the water that is transferred within a cooling tower type of system. So in doing so, you're getting, again, both an air conditioning and a water savings that's quite significant, and again, with a relatively short payback. And we have a fresh air intake control system as well, which detects through noise, temperature, as well as infrared, the level of occupancy within a room, and it therefore kicks in this case, the fresh air intake, therefore maintaining, in this case, indoor air quality, but also significantly reducing, in this case, the consumption within the fresh air intake, right? So you're not taking in fresh air when you don't actually need it. And finally, all the systems are wired together with an intelligent building control system, which again is like an intelligent BMS, and that leads to more savings as well. So with all this, we've taken down the energy usage intensity from 167 to 115. That includes also chiller optimization, AHU fans, the lighting that I talked about, as well as on-site renewables. And this is the list or the greatest hits of all the solutions that we applied in this building, with the sheer focus of making it a net zero building. So what is the case for sustainable buildings really is that even though there's CapEx, you do get your payback within a short amount of time. So as an owner-operator, it makes sense. Even as an investment, it makes sense. Just for the landlord spaces alone, we saved about $400,000 per year, including the tenancy spaces. The collective savings is more than 1 million. And of course, there's improved indoor environmental quality and an uplift in building value. And this continues into a redevelopment project that we're doing. This is a 33-story building in downtown Singapore, smack in the middle of the heart of the city. And in this case, we're also looking at an even lower EUI, or energy use intensity, of 110 compared to the previous 115. So this being a redevelopment, we've got more opportunity to upgrade the systems even further. This is how the building looks like. It's 33 stories with various amenities. In this case, you've got open spaces. You've also got this veil that hides what is a POPS, a private-owned public space. And it's sort of a deal between private developers and the government to actually create open urban spaces and have the private sector, in this case, the development, actually pay for it. But what it does, it brings in the community. It brings in both, in this case, the tenants of the building, as well as the surrounding community towards your building. So with a veil, or a more sustainable facade system through its envelope thermal transfer value that's fairly low, and also through relevant screening, we've I think created a first line of defense for the building. And this is the public space that I was talking about, right? So you can have all sorts of activity down from spin classes to yoga to high intensive training classes that young people are engaged in these days. At the workstation level, you've got various, I would say, amenities also at the workstation level. So you've got facial recognition that comes in and recognizes, in this case, you being an occupant of the building. You come in, you're led to the room that you booked for the day, for instance, if it's a hot desking environment. And even within your own workstation, you've got efficient user control air conditioning, as well as indoor air quality and indoor lighting quality management types of solutions. And as you're working, for example, in this environment, this is a lounge that continues all the way with the same connectivity all the way to your work desk as well. Here's a little pool. Well, it's not very little. It's a fairly large pool, I would say, a swimming pool for the tenants and occupants of the building as well, that looks down onto restaurants into the public spaces below. And finally, a project here in China that, again, is part of the new Park Avenue Central District. Through, in this case, the application of similar technologies, we've got 18 sustainability solutions, and we've actually reduced the energy consumption by more than 25% compared to a benchmark building in China. Likewise, with a similar strategy. And what you see here is IBMS is actually the intelligent building management system that through AI actually detects your consumption and preempts against any failures accordingly. So we've seen a good rental benchmarking with pre-commitments, basically indicating that the market really is focused more towards green buildings, more towards decarbonization, as well as the adoption, and in this case, the embracing of artificial intelligence. And I'll leave you with some images of this building that's going to be completed at about this time in 2024 next year. So, SIR, or Sustainable Urban Renewal, creates greener, healthier, and indeed better spaces. But I'm just going to leave you with a quick little presentation or quick few images on what we call our nearshore township, which is a bit of a floating structure that we're designing off the coast of Singapore. So when we talk about net zero, it's also about resilience. It's also about, I would say, retaining, in this case, the use and function of, in this case, our island of Singapore, and therefore protecting our coasts. So this year, or in this case last year, if there's no rain, this is what the merlion, the popular merlion in Singapore, would look like. If there's flash floods, this is what it might look like. And by the end of the century, this is what it might look like. So the creature might actually have a chance to finally swim. But these are various modes of adapting to climate change from all around the world. Typically, you will build bunds, you will build seawalls, and so on. What we're also trying to do is to engage with nature-based type of solutions and the creation, in this case, of a floating structure. So how do we do that? Is by going offshore or close to the shore and creating a bottom-sitting type of environment and allowing for floating structures to be attached to these environments. And because they're attached and they're also bound together by a hexagonal lattice, they tend to be quite rigid and robust in structure. And of course, this development would then be low waste, low emissions, with as much circularity as possible, and also the ability to self-sufficiently fund or self-sufficiently supply its own power through both renewables as well as power that's off the grid, including in this case district cooling solutions that first of all would be cooled by the sea and also enable the developments to be collectively cooled through a larger infrastructure. Right, so the proposition creates multiple new forms, in this case, of a new real estate. It could be experimental. It could also introduce a new lifestyle type of environment, both recreation, schools, living, labs, campuses, and so on, that you could find and you could actually modulate within such an environment. And that's our solution for climate resilience. So in Singapore, there's the Singapore Green Plan that was introduced a couple of years ago that leads us towards a resilient future. I think we're very much aligned in terms of what the World Green Building Goals are, as well as what the Indian Green Building Council goals are in terms of decarbonization. And with that, I thank you very much for allowing me this opportunity to share with you.
Thank you, Mr. Han, for this very interesting presentation. I hope all the attendees have liked this presentation. A few interesting facts which you have highlighted in this presentation. I would like to summarize it. One is your very ambitious decarbonization goal or vision which you have established, for becoming net zero by 2030. It is very interesting. And one of the most interesting things, which is very relevant for Indian context, is also retrofitting of the buildings which you are doing. Because in India, we also have a very large portfolio of buildings which require retrofitting, which require capital investment to make them, worthy in today's environment. And we are talking about a high performance buildings, which yields a very good rental returns apart from great capital values. And thank you very much for giving this great insight to all the audience here. You have also talked about near shore townships, which are self-sustained townships, which is very interesting concept, which we will witness in future across all the island nations which are being developed across the world. We have a couple of questions here, which I would like you to, answer. There is one question from Dipali Malik, which is for Mr. Han. So the question goes like this. Does the annual cost saving of 1.2 million Singapore dollars has been calculated on the basis of annual conventional O&M cost, or any adjustment has been done for the internalizing the capital investment?
Yeah, that's a great question, actually. Very often, I would say audience would take these figures at face value. But you realize also I shared the annual cost in terms of the O&M period versus the original payback cost. So the payback cost would have been amortized already because most of the solutions had its payback within the first 3 years. And if you notice, I actually shared that it was a pre-2019 and a post-2019 renovation. Because it's just an internal renovation for the most part, it was quite quick. Because it was quite quick, business as usual could actually continue. So the tenants didn't actually see much disruption, because it was hoarded up very strategically and in phases. Now, assuming that you don't have rental loss as a result of this, first of all, your income will continue to come in. Second of all, with the grant that was supported by the government that covered about half to two-thirds of the cost, that payback is actually brought down even further. So assuming that the income and the savings that you actually get from both the continuing rent, the rental uplift, as well as the cost savings, all this sums up in the net operating income, and it amortizes the original capital expenditure of all these equipment and all these technologies within the first few years. So the 1.2 million Singapore dollars is indeed the O&M cost following, in this case, the amortization of the initial capital expenditure. And that is useful to note because you could come up with different metrics with different figures depending on whether or not the building is upgraded for your own occupancy, for leasing, or ultimately for sale and for divestment. In which case, your metrics could actually change accordingly. But the sum of this is that you're basically getting quite a few, I would say, decent or more than a decent percentage of savings, and it therefore makes the investment case worthwhile for sustainable urban renewal.
Okay, great, Mr. Han. So I have also one question, Mr. Han. Is there any legislation or policy in Singapore which mandates the old buildings to go for retrofitting? Is it mandatory for the old buildings after some years to go for retrofit?
Not specifically, meaning in the sense that you don't necessarily need to retrofit your buildings. There's also a case that can be made for redevelopment, which is the strategy that we took for the second project that I showed, Capital South Central. And that is because, for example, the gross floor area can be optimized far more, meaning the entire building becomes a lot more efficient, not just in terms of energy performance, but in terms of how the entire asset, performs both commercially as well. And very often as commercial endeavors, these sort of discussions actually would come in. But that means as long as we redevelop, we try to make it as efficient as possible, such that you amortize, first of all, the carbon expenditure as well as your cost expenditure within, of course, 5 to 10 years, which is a point that M. Undurkar is making as well on the chat. And that's a great point as well. So if you have any tax relief, for instance, that will actually highlight, or I would say that would actually encourage such behavior. And likewise, if you have financial institutions that can actually provide for these loans with either interest rebates or interest free within the first few years, in order to encourage green behavior. Now, that's really one way of encouraging, in this case, the redevelopment of buildings to make them a bit more green, or the retrofit, depending on what the need might be. I might have lost you a bit.
Yeah, I think he has some
Apologies.
power.
Yeah, am I audible now? Am I audible?
Yeah, now audible.
Not
Yeah.
audible. Yeah.
Himanshu? Okay, great. So I have one question for Mr. Shiva Kumar. Also, like IIT Madras, how they are helping construction industry, primarily developers, in shortlisting technologies which are greener in nature, which are environmentally sustainable in nature. So, is there a specific publications which you are doing for developers, architects, and other stakeholders in the industry, sir?
Uh, the two recent initiatives from IIT Madras are first is as a part of the Institute of Eminence scheme, we have created a research center called Technologies for Low Carbon and Lean Construction. It is called TLC2. It was created recently, and as a part of the center, we address the complete life cycle, solutions from a material perspective, solutions from a management perspective, more from a policy perspective. So it's a well-rounded initiative towards sustainability in the built environment. So the second initiative from IIT Madras is the School of Sustainability. It has been launched recently, and my colleague, Dr. Ashwin, is the head of School of Sustainability. One of the goals is to integrate the research efforts across the 10 plus departments in our campus and provide a more coordinated approach for addressing the technology solutions related to sustainability. So these are the two initiatives recently started from our campus, along with the international efforts like this IEA Annex 72 committee focused on life cycle impacts of buildings, and now they have started a new Annex committee on whole life cycle carbon neutral built environment. So we have initiatives both at the national as well as at the international level.
Okay, great.
So I hope that
Thank you
answers.
so much.
Yeah.
Thank you. So we have one last question for Mr. Han. So what are the challenges you are facing in Singapore to bring in net zero waste solutions to existing buildings? Mr. Han.
Yeah, I'm not sure if you can still hear me. Yeah.
Yeah, we can hear you.
Okay, great. Yeah. The net zero waste tends to be a bit more difficult from a commercial angle because currently we don't have large waste taxes quite as yet. And we'll find that a lot of the movement towards green buildings, first of all, comes in policy, but also comes in the fact that it really makes a good business case now that the energy tariffs are high, right? And that's, that's really hitting where the savings are. That's really ensuring that you're putting in all these solutions such that there's a good business case to it. So that's the main challenge. Of course, that's in some ways is I'd say resolved by policy. It's also resolved by the fact that general behavior is also shifting more towards sustainability practices. So we do take small steps, for example, using recycled materials, using high circularity type of strategies in our redevelopment work, and that includes the recycling of any demolition material, for instance, where any demolition also does happen. Yeah, but primarily I think there's not a strong commercial case yet for low waste or zero waste type of development.
Thank you, Mr. Han. So I think we can conclude this session. This year's theme for World Green Building Week is Building the Transition. And the theme underscores the urgent need to transition towards building that produce little or no carbon emission during their life cycle. It aligns with global effort to mitigate climate change by reducing greenhouse gas emissions, as buildings are a significant contributors to building emissions worldwide. This session has put a tremendous, effort in explaining about how we can create a sustainable construction practices in built environment. And thank you very much for all the participants, and thank you very much for the speakers. Thank you so much.
Thank
Looking
you.
forward for more sessions in this Green Building Week. Thank you, IGBC team also.
Thank you, IGBC.
Thank you.
Thank you. Bye.
Thank you.
Thank you, man. Thank you,
Thank
Shiva
you.
Kumarji. Thank you. Thank you so much for joining us. Thank you.
Thank you very much. Thank you.
Thank you, Sachinji. Thank you.
Thanks,
Bye.
Manchu. Thank you.
Have a nice day.
Bye.
Thank you. Bye.
There are some questions in the chat box. I hope you'll be able to answer later.
I think no, we'll take care. We'll see.
Okay. So one from Gopal and on green building ratings. Should we give some inputs to them or?
No, we'll share our feedback and we'll try to address them. No.
Sure. Thank you.
Thank you.